Welcome guys to a new video. This one is about trigonometry, past paper question. So let's have a look. Question A, show that sine of 2x plus cosinus of 2x minus 1 equals to 2 sine x times bracket cos x minus sine x. I wrote here the double angle properties that might be useful to us. You have them on the formula list. Let's try and use them. So I'll try to do some substitutions here. I have the left side, I have the right side. I'm gonna try to open the right side and prove that it's equal to the left side. So I'm just gonna take this part, work it out over here, and then check if it's equal to the left side. So 2 sine x, and then I open the brackets. I multiply with cosinus of x, and then minus, I multiply 2 sine x with sine x, which becomes 2 times sine squared x. I hope this makes sense. Then we carry on. We have here 2 sine x cos x. This, according to the formula, is just sine of 2x. So I'm just going to write that. Sine of 2x minus this thing is close to here, right? It's almost cosinus of 2x. So I'm actually going to do that. I am going to write minus 2 sine squared x, but then to make it equivalent to cosinus of 2x, I have to have 1 as well, a positive 1. So I'm going to do positive 1, but because I added a 1 which was not there, I have to subtract it as well. In this way, I keep the exact same shape of this expression. I added 1, I subtracted 1. However, the reason for doing so was to show that this thingy is just cosinus of 2x. So I'm going to write sinus 2x plus cosinus 2x, and then I have the minus 1 from here. This apparently looks very much like the left side over here, so we showed it. We just showed that the right side equals to the left side. Okay, so that's nice. Now let's have a look at question B. Hence or otherwise solve the following equation for x being between 0 and 2 pi. So we have to solve for x. Now to solve for x, obviously we would like to factorize, because at this very moment we can't do anything about it. This is just not even close to a proper answer. So let's try to clean this up. I'm going to write this underneath and start solving. So we have over there now sine of 2x, we know the double angle property. We're gonna write it. I'm trying to use whatever I have at my disposal, because usually the questions are such that we can apply some of the rules we know about trigonometry to factorize and solve. Otherwise they wouldn't ask the question in the first place. So always try to use what you know. Double angle properties are a classic that can be applicable pretty much in most questions. So we have this one, plus we have cosinus of 2x. Cosinus of 2x we can write as 1 minus 2 times sine squared x, and then I'm just going to keep writing the rest. This thingy I have to write as it is, minus 1 plus cosinus of x minus sinus of x equals to 0. I do that and I'll carry on. Plus 1 minus 1 cancels out, so I'm going to eliminate this. Then I can group this term, which has 2 sin x, with this term which also has 2 sin x. So I'll have 2 sin x cos x minus 2 sin squared of x, and then I have plus cos x minus sin x equals to 0. Then I'll carry on. What do I have here? I have sin x as a common factor, so I write 2 sin x bracket cosinus of x minus, here I have sinus of x. Okay, and then I have cosinus of x minus sinus of x equals to 0. Then I can identify some other thing, which would be this one, cosinus of x minus sinus of x. If I treat this as a common factor, I can factorize this expression further. I'm gonna put bracket cosinus of x minus sinus of x, and then I have 2 sin x as one factor from the first term. Because I factorize cos x minus sin x, the only thing left here is a 1, so 2 sin x plus 1. Now this is looking so much better, because we can actually solve it. We factorized, we have a multiplication of 2 terms, and we know that the multiplication of 2 terms equals 0 when either of the term is 0. So cosinus of x minus sinus of x equals to 0. and we should also solve 2 sinus x plus 1 equals to 0. I will solve each one in part. First of all, I'll solve cosinus of x minus sin x equals to 0. That's equivalent to say cosinus of x equals to sinus of x, since I just transfer to the right side. Then I can identify the fact sinus of x divided by cosinus of x equals to 1. In other words, tangent of x equals to 1. Now we have to make use of our unit circle. If you guys remember the unit circle, if I were to draw a unit circle where we have the radius of this circle as 1 to apply some trigonometric rules, the tangent of x was equal to 1 at 45 degrees. That's something you want to remember. So roughly speaking, if we were considering this as 45 degrees, here the sine and the cosine will be equal. Because our question tells us to write the answer for x in radian, remember, they say solve the question for x between 0 and 2 pi radians. Okay, so radian wise, x equals to 45 degrees is equivalent to saying that x equals to pi over 4. Okay, now I hope you guys remember the quadrants in a unit circle. First quadrant, second, third, and fourth. And you should also know the fact that when you have such quadrants, the values of the cosinus and the sinus is as follows. So if I consider a point with two coordinates, and let's say theta is going to be an angle of reference. Theta could be such an angle, theta could be a larger angle. Theta will be the angle of reference, and if I were to look at the coordinates of such a point on the unit circle, the first coordinate gives me cosinus of theta, the second coordinate would give me sinus of theta. And you need to know the following on a unit circle, that in the first quadrant they are both positive, cosinus and sinus. In the second quadrant the cosinus is negative, the sinus is positive. In the third one both of them are negative. In the third quadrant both of them are negative, and in the fourth quadrant you have the cosinus as positive and the sinus as negative. Why is that relevant to us? Well, think about it this way. Because I know that I have 45 degrees as a solution for tangent equals to 1, the 45 degrees is not the only solution, because if I were to look diagonally in my third quadrant, I would basically replicate the same kind of triangle that I have over here. Okay, but this time both my sinus and my cosinus of this angle theta is going to be negative, and we know that a negative divided by a negative number gives us a positive answer. So technically this theta is going to give us the same tangent value of 1. However, where is this angle? Well, I just extended it by, so I just moved another 180 degrees towards the third quadrant, or counterclockwise. In other words, what I just did was pi over 4 plus pi, since pi represents 180 degrees, pi radians, right? And then if I were to do the common denominator, I multiply this by 4. Pi over 4 plus 4 pi over 4 is just 5 pi over 4. So the second solution here is 5 pi over 4. In conclusion, so far, x equals to pi over 4, x equals to 5 pi over 4. These are two possible answers already, but we are not done because we have to solve the other bracket. Now, for the other bracket, I go back and I will solve it. This one. 2 sinus x plus 1 equals to 0. Make sinus x the subject. 2 sinus x equals to minus 1. And then sinus x equals to minus 1 over 2. Okay, minus 1 over 2. Now the sinus must be minus 1 over 2. First of all, you should remember that sinus of 30 degrees, or pi over 6, is 1 over 2. My question was to find sinus of x to be minus 1 over 2. Now remember what I said, that the second value in my coordinates is the sinus. So I wrote it over here. Minus 1 over 2 for my sinus has to be over here, minus 1 over 2. Because in this case, my y coordinate, which is the second coordinate of this point, is negative. So I will just go 30 degrees down, okay? In this case, I can say that the sinus of theta is -1/2. But to give the answer for my theta, I cannot write as -30 degrees, because the question said that x must be between 0 and 2 pi radians. So I will do the following. I will write the answer as a positive number. And how can I write that answer as a positive number? I write it considering my starting point as the positive x side. So I go all the way counterclockwise like that. And this will be one of the answers. Now, I hope you can understand that's just a full circle of 2 pi radians minus pi/6, which is 30 degrees. So my theta, in this case, or since I work with x, I'll just keep it as x. My x is going to be 2 pi minus pi/6, which is 11 pi/6, which is one of the answers. I am still not done. And I'll explain why I'm still not done. Because since I want my sinus to be negative, 1/2 is a positive value. I discussed that in my fourth quadrant I had a negative sinus value. Where else do I have a negative sinus value? Right here. The sine of x is negative in the third quadrant as well. So now I can take my 30 degrees and I will just go by 1 pi counterclockwise to reach this point. And in this case, I will have one more answer. So my 30 degrees, I have to go this way, okay, to make it sort of a reflection in the other quadrant, so that my sine is going to be negative 1/2. Here it was 1/2 in my first quadrant. Here it's going to be -1/2. And that answer for me is just going to be pi/6, since pi/6 is 30 degrees. And because I moved 1 pi radian counterclockwise, I'm just going to add a pi. So my other answer is going to be pi/6 plus pi, which is going to be 7 pi/6. So in conclusion, we have 4 answers to this question: pi/4, 5 pi/4, and then 11 pi/6 and 7 pi/6. Hope this all makes sense. We are done. If you like the video, please drop it a like. If you need to watch it again part by part, since it was a very long one, please do so. It's gonna help you. If you follow the AA standard level course, make sure to subscribe. It's gonna be full of relevant content to you. Thank you for watching. See you in the next one. Bye.